Hello and welcome to the third part of Applied Handbook 2 and the second part of measures of location and spread. In this video we're going to focus on a technique called interpolation. Now just a little note, I'm not really going to go through what's on page 14 here because it kind of contradicts what we then do on page 15, but just know this page 14 is what we do if we've just got singular values. Okay, it's not in the data is not grouped. Okay, it's all just discrete data. Then you'd use these rules. Okay, but to be fair, finding upper, lower quartiles and median from just a set of data like this is very much a GCSE level skill. So it's very rare that you'd be asked to do this in an A-level exam, but it is worthwhile making yourself familiar with these rules, what you do. And then I filled in the example there for you. So if you want to complete all the notes, this is how you would find Q1, Q2 and Q3, your lower quartile, your median and your upper quartile, this set of data. Notice the kind of symmetry here with the values. I'm not going to go through this in too much detail because what I want this video to be the focus of is interpolation. Okay, and what I'd be doing is these rules that we're giving you here are different to the rules that we're going to introduce in a second. This is what we need to do in the exam. Okay, so there's different rules for different types of data, but we're going to move on to for when we've got group continuous data. Okay, slightly different rules. The reason why it's slightly different rules is because we're going to be estimating, and we've also got, usually we'll have quite a large amount of data. So what we're doing here is we're finding the lower quartile. So the lower quartile is your 25% mark. Okay, anything, all the values below that in the bottom 25%, everything above that is in the upper 75%. Your median is Q2, we all know that, but the difference here is when we find the median, we're just going to half the number of values we've got and we're going to take that value. So it's a bit contradicts what we talked about right at the start, that if we said we had 10 values, we'd say, well, we have the fifth and sixth value. Here, what we're saying is if we've got 200 values, we're just going to take the 100th as our median, even though technically it's the 100th and the 101st. We're just going to use that. We're just going to use the half of that value. And then Q3, the upper quartile, that's the 75%, 3/4 of the way mark. Anything above this value is in the top 25% of your values. We just use 3/4 of n, or 75% of n. Then we'll have the nth percentile. So for example, if you have the 10th percentile, you'd find 10% of n, and this would be a 10th percentile. Anything below this value is in the bottom 10%, anything above it would be in the upper 90%. Okay, depending on what your value then is, just using 10 there as an example. So when we're using interpolation, what we're doing is we're finding an exact value for the median. Now it's still only an estimate, and the reason why it's an estimate is because we don't know the exact values when it's group data. But what we can do is we can make an assumption that the data is spread evenly. Okay, which is a good assumption to make. Okay, it might not quite work like that in reality, but you know, it's the best way we're going to get the best estimate possible. So in this example, you've got the time to nearest minute people spent on Facebook per evening by a group of students, and we're going to find estimates for the median. Okay, so previously we've looked at how we find the median class. Okay, and what's going to help us do that is having a cumulative frequency total here to the side. Okay, so this is a cumulative frequency. So what this means is 2 people spent between 30 and 31 minutes, and then 27 people spent 33.5 minutes less. I'll explain why I said 33.5 in a minute. And then 57 spent 36.5 or less. So that includes all your previous values as well. So just remember that definition of cumulative frequency. So we're going to start off by finding the median. So firstly, we need to find out what value that's going to be. So we've got 70 values, so I divide that by 2 for 35. So the median is the 35th value that I'm trying to find. Okay, so I'm trying to find the 35th value. Okay, yet again, that does contradict previous definitions, but this is what we're going to use when we've got continuous group data. So I know the 35th value, it's not going to be in the first row here. It's not going to be in the second row here because it only takes up to 27 values overall. I'm looking for the 35th, so it's not going to be in any of these first two rows. It's going to be in this third row. So it's going to be between 34 and 36. But we talked about previously how, because these times have been round to the nearest minute, the lower bound is not 34 and the upper bound is not 36. Actually, the upper and lower bounds are going to be different. Okay, the reason why is if you had a time of 33.5 minutes, it would come into this third row. So the actual lower bound is going to be 33.5 minutes. In the first video on this, pages 1 to 8, right at the end, we do an example like this. I think it's actually the exact same data. If you just want to go back and look at why our upper and lower bounds are 33.5 minutes and 36.5 minutes, but just to kind of briefly remind you, 33.5 minutes, the lowest it can be and still be rounded up to be in this category here. 36.5 is the highest it can be and still be rounded down to fit in this category. Technically, it's 36.49 recurring, but we're going to use 36.5 because 36.49 recurring is so close to 35 minutes. So what I'm going to do is I'm going to use a number line to find this median here. So I know it lies between 33.5 and 36.5. Okay, so I know the median is somewhere in between there. Now, this is your 27th value and your 36.5 is your 57th value. Okay, and you're looking for the 35th value. Okay, so you'd expect, just as a little estimate, you expect it to be closer to the 33.5 than the 36.5. Okay, because the cumulative frequencies go between 27 and 57, 35 is close to 27. So we're trying to look for this value here, which I'll call x. Now I'm going to show you two different ways of doing this. I'll do two different examples with two different methods, and you can pick which one you like the most. So for 27 and 35, there's 8 values there altogether. And what I'm going to look at is how far into the line this is. Okay, what fraction of the way is this number into the line here? So the whole width of this line is going to be 30. So you've travelled 8/30ths of the way into the line. Okay, just imagine if you were looking for the exact halfway point between 27 and 57, you just find halfway between 33 and 33.5 and 36.5. But it's not quite, okay? We want it close to 33.5. So now what you need to do is consider how long this line is, okay? Well, this line has a class width of 3, and it's still the same fraction, okay? Still the same fraction of the line to go from here to here. So what we need to do is work out what 8/30ths of 3 is. Okay, so the whole line has a length of 3. We want to go 8/30ths of the way into that. So we're going to do 8/30ths of 3, which is 0.8. Of course, that doesn't make sense to be the median. What we need to do is add 0.8 on to the 33.5, your lower bound. And that is 34.3. So Q2, your median is 34.3. So that method, to be fair, that's not one necessarily you see in textbooks. That's just more of a kind of logical approach to it. It might work for some people, it might not work for others. So I'll show you the more kind of traditional way that you'd see in the textbook in the second example. So the second example, you're looking for the upper quartile. Okay, so the upper quartile, remember, this is 3/4 of the way along. So what we do is we work out 3/4 of 70. It's going to be 52.5. So you're looking for the 52.5 value. Don't worry if that doesn't make that much sense that you're actually finding the 52.5 value, okay? Basically saying it's between the 52nd and the 53rd value, okay? You couldn't just say, oh, it's the 52nd or it's the 53rd. We'll take halfway between. Remember, we're only finding an estimate, so it's fine that we're not necessarily using whole numbers here. So we're looking at the 52.5 value. Don't round that number up. or anything. Even if you've got like 52.25 or 52.75, don't round up or down. Just use this number in your calculation. So this method is very similar to what we just did before, but if you prefer kind of subbing things into formulae, then this way might be better. This way might work better for you. So the 52.5 value, it's not in the first row, it's not in the second row, it's going to be in this third row because that takes you up to the 57th value, and we're starting at the 27th value in this category here. So you know it's going to be this one that we're looking at. So remember, yeah, again, it's the same class intervals before. It's between 33.5 and 36.5, and that takes you from 27th to your 57th value. Okay, this time though, it's going to be much closer to the 36.5. So when I'm doing it this way, what I'm going to do is I'm going to start at the top line here. I'm going to start by saying, okay, well, if I do x take away 33.5, so I'm still doing the same thing of really working the fractions, just slightly different way of looking at it. Okay, if I want to work out what fraction of the way along this line this dot is here, I do x take away 33.5, so find out how far you travelled from the start to get to x. How far do you have to travel across the whole class width altogether? So that's 36.5, take away 33.5. So think of it as you do x, take away the lower bound, 36, your upper bound, take away your lower bound on the bottom. So x take away 33.5, 36.5, take away 33.5 on the bottom. This fraction will be the same as what you've got happening down below. So down below, work out how far you travelled. So you've gone 52, so you do 52.5, take away the 27. So we do this, take away this, and the bottom we do the 57, take away 27. So 57, take away 27, and so. It's up to you how much you want to kind of tie this up before you put it in the calculator. If you want to, you can just simply put in this fraction, times it by this one, and then simply add the 33.5 on. Depends how many steps you like to do it in. I'm just going to show you how actually it ends up being very similar to what you do had you done it the first way that I showed you. Because what you've done the other way is worked out that's 25.5 you travelled out of 30 altogether, and then the width here is 3, and then you need to add the lower bound onto it. Okay, so it's up to you how many steps you want to take. You might just want to sub this all in your calculator and rearrange right away. Whichever way you do it, we should get Q3, the upper quartile. This should come out to be 36.05. Okay, I'll just check that fitted on the screen there. Yeah. Okay, and then finally, whichever way you prefer doing your last example. So you're looking for the 10th percentile. So we just work out 10% of 70. Okay, that's not going to be too hard. That's 7. Say you're looking for your 7th value. And your 7th value, well, it's not going to be in the first row, it's going to be in the second row. Okay, so it's going to be, well, it's not between 32 and 33. Remember, it's going to be between 31.5 and 33.5. So just make sure you've got your true upper and lower bounds here. Okay, and this takes you from the second value to the 27th value. So just make sure you've got your correct frequencies. And we are looking for the 7th value, okay? Whichever way you do it, this diagram is really important, really help you. So whichever way you prefer to do it, I'll just do it the first way. Working out the fraction, so we travelled 5 along the line to get the 7, and then the whole width of the line is 25. So we travelled 5/25 of the way along the line. Looking above, well, there's a whole gap of 2 there. So we do 5/25 of 2, essentially a fifth of 2, which is just going to be 0.4. And then we just add that 0.4 onto the 31.5. The 31.9. So Your 10th percentile, which we say is P10, is just going to be 31.9. So it means 10% of people spent less than 31.9 minutes on Facebook, and 90% people spent over 31.9 minutes. Okay, so any questions, leave them in the comment section below, and in the next video we're going to look at measures of spread and also how we can use interpolation as well to find things like Q1, Q3, and then find things like your interquartile range or interpercentile range.